Hello, good morning everyone. Sorry for the delayed resume of the video because I was involved in finalization of paper to some important journal like New England Journal of Medicine, Lancet, Infectious Disease, Clinical Infectious Disease journal. So there I have submitted to them. So sorry for that due to delay for the resume of the video. Today we will be starting with the Hematology and Oncology chapter of the first aid revision, and we'll deal with the hematology. On hematology, if you want to know begin, then we have to know about the hemoglobin and different types. Okay, so talking about the fetal erythropoiesis. Fetal erythropoiesis, you know, is the process and production of RBC, okay, in our body, and that erythropoiesis occurs since fetal life. And initially, the fetal erythropoiesis occurred in the yolk sac, the liver, spleen, and bone marrow. These are the four organs that is responsible for the formation of RBC, that is responsible for erythropoiesis. Okay. Now talking about the yolk sac, the initial stages you can see in this diagram about the site of erythropoiesis. This is yolk sac, this is the liver, this is the spleen, and this is the bone marrow. You can see that yolk sac, the erythropoiesis begins at 3 to 8 weeks of your life. So very early stage you will find that erythropoiesis is contributed by the yolk cell, and that is from 3 to 8 weeks. It starts from 3 weeks and we end at the 8 weeks. Before it stops the erythropoiesis, liver comes into the action. Okay, and what does liver do? Liver also helps in the erythropoiesis, and that's begin at 6 weeks. You remember there is an end of erythropoiesis in yolk sac at 8 weeks, but before that in 6 weeks liver starts to synthesize the RBC, and it continues up to the birth. So this is the birth, this is from your fetal life, and that is postnatal life. Okay, now in between the spleen also contribute for erythropoiesis, and that start from the 10 weeks of your life to 28 weeks of the life, and it stops. So yolk cell initial stage, then liver comes into the play and take the responsibility, then spleen came, the spleen takes from 10 to 28 weeks, and finally the bone marrow, which is for the adult. Now every adult has erythropoiesis in the bone marrow, and it begins its action from the around 18 weeks of the life and continues to the adult. So how we can remember what are the site for erythropoiesis? That is the formula, that young liver synthesis blood, that is yolk sac, L for liver, S for spleen, and B for bone marrow. So in this way we can remember this organ, and it is necessary to know. The important thing is that you at least know what are the organs, and you should also know that initially it was the yolk sac, then comes the liver. Liver can start around the 6 weeks and continue till birth, then it stops. Spleen in between takes some role and contribute for erythropoiesis, and finally the main is the bone marrow that comes at 18 weeks of your life and continue erythropoiesis till adult. That is important. Okay, so when we come to this picture, this is the thing. There is an important point you have to understand about the hemoglobin development. Initially, embryonic globulin, if you talk about, that is the zeta and epsilon. These are the globulin that takes part in formation of embryonic globulin. Then comes to the fetal hemoglobin. In fetal hemoglobin, hemoglobin F, also known as the hemoglobin of F, it has two components, alpha 2 and gamma 2. But look, the fetal hemoglobin has an important property to bind, to extract the oxygen from the mother blood, mother RBC, because it has a tendency not to bind with 2,3 ppg. So since it has less avidity towards 2,3 ppg, it has more avidity, more binding, and more capacity to extract the oxygen from the mother blood, mother RBC. Oxygen from mother RBC. That is the property of your fetal hemoglobin, and it is required because we know that in fetus the only source of oxygen for and nutrition to the baby is only the mother. So the nature has to design something that can extract more oxygen from the mother RBC, and that is the property of your hemoglobin F. It has that property because it binds less avidity to the 2,3 ppg. Do you understand that point? Okay, now let's move towards the fetal hemoglobin. Now we have moved towards the adult hemoglobin. Now look, in birth, in fetal life, you have this hemoglobin predominant, but when we comes to the adult, when we grow significantly, then there is the conversion of this fetal hemoglobin into the adult hemoglobin. Adult hemoglobin are two types, hemoglobin A1 and hemoglobin A2. Okay, now talking about the hemoglobin A1, it has two components. Look, there is alpha and gamma. Here comes alpha and beta. Okay, this was the most abundant hemoglobin found in us. If you are examining our blood hemoglobin by electrophoresis and other thing, then you will find this is the predominant in normal portion. If it is not predominant, if you are finding this hemoglobin, then that is a problem. If you are finding this A2 in the more amount, then there is a problem, and that is the pathological state. So you have to know, initially in fetal life you have hemoglobin F. Then when you comes from the fetal life postnatally, this will convert it into the hemoglobin A1 and some amount of hemoglobin A2. The difference is hemoglobin F is alpha 2 and gamma 2, whereas hemoglobin A2 is alpha 2 and beta 2, whereas hemoglobin A2 is alpha 2 and delta 2. So what you need to remember, hemoglobin adult one, that is alpha 2 and beta 2. Okay, hemoglobin F alpha 2 and gamma 2, and alpha beta and alpha beta delta and gamma. So alpha beta is hemoglobin A1, which is predominant in adult. Okay, alpha beta alpha delta is small amount, but that is present in normally in adult, and hemoglobin F is alpha and gamma. So you understood that. Now there is a formula to remember, that alpha always remains. So if there is alpha, every time remains. Gamma goes away. This gamma was in fetal life, that goes away and becomes beta. So beta remains, which is the predominant. In fetal life, this is predominant. In postnatal life, it becomes the adult one, that is predominant. If you see this same thing over the your period of life, then you will understand. Look, this is the embryonic globulin. In embryonic globulin, there was zeta and epsilon. Now what happened? This alpha remains always. Okay. Now there is another is gamma. This alpha and gamma was responsible for hemoglobin F. This is before birth, and the predominant amount of hemoglobin F is present in your body in fetal life. Okay. There is no other hemoglobin most predominantly. This is only the hemoglobin F, that is before birth. See, before birth, this is hemoglobin F. After birth, you can see that gamma goes away and this beta comes away, and this form the hemoglobin A2. So around adult and after 42 weeks of your postnatal life, you will have predominant amount of hemoglobin A1. That is important. So if you understand this is hemoglobin F before birth. After birth, this is postnatal life. Postnatal means mainly you have to understand that not postnatal, this is after birth. That is, yes, postnatal, after birth it is made, and that is hemoglobin A2, which becomes predominant in adult, and that you have to understand. If this pattern is not followed in electrophoresis, then you have some pathology, and you have to understand that. Okay, so let's end this chapter over here. Then we'll continue our thing in next lecture, and we will revise the first step initially. Maybe we will continue with hematology and end it, or either we'll go directly to the microbiology part, because microbiology will be a long chapter, and I think I'm expert in infectious diseases. Then first I have to concentrate and make clear that point of view. Then we'll come again back to this. Let's see what's working. Okay, thank you.